If you were a life form on a pristine planet, what is the first question you would ask exploratory humans?
So first, let me say, go to an old episode of The Twilight Zone called The Invaders. In that episode, Agnes Moorehead is this lone ranch woman on a little house in the prairie, and you just have to watch that. It's called The Invaders. Point is, if I'm the other life form and I see humans, my first question would be, have you come to colonize this planet? Because if that's your goal, that's not happening, okay? This is StarTalk. Neil deGrasse Tyson here, your personal astrophysicist. We're going to do cosmic queries today, except today I have Paul Mecurio. Paul.
Oh, what's up, my friend?
Welcome back to StarTalk.
Great to see you.
What'd you do with Chuck? What'd you do?
You know, he's in a bag somewhere. he's last time I checked, he was breathing.
He was still breathing. So how you been, man?
I'm good.
I miss you. I miss you still doing the Late Show.
Doing the Late Show with Stephen Colbert. Just did another appearance on that. I've been touring with my Broadway show, Permission to Speak, directed by Frank Oz.
Frank Oz. He's the voice of Yoda.
He's Yoda. He's a mensch, as they say. He's just a brilliant artist.
We love him. He's been on our show. You can find him in our archives.
He's
Frank
amazing.
Oz.
And he's just...
And you'll see how the breadth and depth of all that he is.
Oh, the Muppet creator with Jim Henson of the Muppet, created Miss Piggy and Fozzie Bear, directed everybody from Marlon Brando to Robert De Niro to me. I don't know what that's about. He's really a step down.
There it is.
I think he's living in his car by the river.
We love. So this is a grab bag.
There's a grab bag. We love these.
And I haven't seen them before.
Nope.
If I don't know the answer, I'll just say I don't know.
Yeah. Oh, you know. You always know the answers.
No.
Okay, here we go. Eric Krasjadoti, Dr. Tyson, and Duke Mecurio. Wow. I've never been called a Duke before.
Oh, because Chuck is called Lord.
Oh.
Lord Nice.
Oh, I didn't. Oh, okay.
Oh, okay. Well, everybody's got a title.
I'm a Duke now. There we go. Ooh, I hope that matters at home with my wife.
But are you Duke of Earl? Duke of Earl.
All right.
They got lower. Duke.
Yo, you can do that. I can do Duke of Earl. We're going to just do this for 30 minutes.
Duke of Earl. Then you got to come in high. Give me some falsetto.
Duke of Earl.
We'll find out what you're Duke of. We'll come up with something.
All right, okay.
Go.
Greetings from Monongahela, Pennsylvania, regarding the idea of time travel and star position. Hypothetically, if I were to create a time machine, attempt to go back to Monongahela 2,000 years ago, would I not end up in empty space because the entire solar system would not have arrived in that location had I had departed from?
Every time machine is also a space machine. They're a space-time machine. They don't say it, but they have to be.
Why is that relevant and why does that matter?
They have to be. Now, they got around that in Back to the Future because when Marty is trying to escape from the Libyan terrorists and he jumps in the DeLorean and he's quickly typing the date, he types 1955, but it's the same day of the year as he leaves. So he goes back to 1955. Earth is in the same part of its orbit
on that
around
day,
the sun
because of the date. The
date was the same. So they skirted.
But that can't be true because over the years.
Hang on. So that they dodged that bullet a little bit. Okay. Had it been 6 months earlier or later, he'd just be plopped in the vacuum of space and he'd be dead. Okay. So the reason why they dodged that bullet is because the entire solar system is also orbiting the center of the galaxy.
It happened to pick the exact date. That was the key there.
Well, only for the moving coordinate system that is the solar system.
Okay.
But because the whole solar system is moving, he goes back 30 years. He's leaving our solar system today. And if he only moved in time, he would be where our solar system is today 30 years ago.
But he also moved.
He would have been well ahead of where the solar system would have gotten. The solar system would need another 30 years to catch up.
But he also moved in space, is your point, not just in time.
Which is why he landed in exactly the same spot on Earth. So it's implicit in the storytelling. So you're absolutely right. You can't do that in any way that makes sense.
But wait, if our solar system formed about 4.6 billion years ago, isn't the premise, part of his question has a false premise, which is I would not end up in space because the entire solar system would not have arrived in the location. The solar system is there in that location.
No. we're in a rotating galaxy. The Milky Way is rotating. And so that is all the stars in the Milky Way are rotating around our central black hole in the center. So if you go back in time, you are no longer where you left in space. And you'll be dropped in the middle of nowhere. So you always have to land in a space-time coordinate in the future. We sort of do that, but without the relativity part. If you're going to visit Mars, you don't aim for where Mars is. You aim for where Mars will be when you get there. Then you intersect Mars.
So if you're going back 2,000 years, it will be an empty city. Well, there's going to be a Home Depot because they existed in a Subway sandwich shop. They've been around. And,
in the mall, yeah.
Well, I mean, their franchising methodologies is brilliant, and they never get enough credit.
So what you need is, you have to know where was the solar system and the Earth 2,000 years ago, and not only move back in time, but move back to that location in
But
space.
you cannot say that the Monongahela would not be the Monongahela 2,000 years ago. Why wouldn't it be? Why would not it be exactly what it is today?
The Monongahela sounds like a native tribe.
It is.
That's who would be there.
Well, that's
2,000 years ago.
But he's asking if I create a time machine, if I have to go back to Monongahela, would I not end up in an empty space?
Yes, he would, unless he moved in time. That's what I've been spending the last 10 minutes describing.
I understand that. So you answered his question is yes.
Yes, unless he also moves back in space.
Space as well.
Correct.
Got it. Okay.
And yes, so every time machine is also a space machine. Otherwise, it would be quite lethal most of the time.
What would happen?
No, you get dropped in the middle of space because everything's moving. You got to move with the action.
Okay. Margot Lane, if you were a life form on a pristine planet watching exploratory humans arrive for the first time, okay, so you're observing humans arrive for the first time.
Yes.
What is the first question you'd ask them, assuming you could understand each other? And I have the answer to this. My question would be, really, you needed Skechers shoes where you don't have to bend over to put them on? That's where you
That
were
meant
as a
you saw our
species?
TV commercials.
Forget about that. That's
that
where
your
we
high
are
technology?
as a species. There's a lot of questions. The Kardashians. What? Why? Really?
What's up with that?
How do people who make Vaseline make any money? Think about it. I've had the same tub of Vaseline. My Vaseline was handed down to me, Neil, by my grandfather in a will. I don't think you understand these conceptual... Okay, here we go. So,
Well, I think people used to use Vaseline before lotion was big.
I used it to grease the brakes on my car, and I still have a giant vat of it.
Big tubs of Vaseline are not as,
You could go through 30,000 bags of garbage. You're not going to find one empty container of Vaseline. All right, so if you're a life form on a pristine planet watching exploratory humans arrive, what is the first question you would ask exploratory humans?
Okay. So first, let me say that you should look online, maybe Pluto TV or one of these things that has old TV in it.
Me TV?
Me TV, yeah. And there's several others as well.
Yeah.
Go to an old episode of The Twilight Zone called The Invaders. That's all I will say.
Well, I watch a lot of Twilight Zone. I'm trying to remember which one that is.
So in that episode, Agnes Moorehead is this lone ranch woman on a little house in the prairie. And it's a one-woman show. She's the only character in it. And you just have to watch that. It's called The Invaders.
Oh, I do remember this now.
It's called The Invaders.
Okay.
Don't say anything about it. Point is, if I'm the other life form and I see humans, my first question would be, just given what I know about humans, have you come to colonize this planet? Because if that's your goal, that's not happening, okay? We will not let that happen, okay? Because we've seen what happens when you colonize stuff before.
Yeah.
Okay?
Yeah.
So that's the first point. Second, that's interesting because that implies that the humans have more technology than the alien in that case.
Doesn't.
Yeah, because otherwise the aliens would have visited us first.
No, you're just jumping to conclusions.
No.
You're missing it. The question you got to ask is, really, you conveyed happiness by a little yellow circle with a smiley face called an emoji? Like, there are so many bigger questions that you could ask these people.
Yeah, that's
true.
true.
The colonization is a good point because nothing good ever has really happened from that. It's good and it's
How about
bad.
this? I would say, how did you survive yourselves? Enough to then come visit another planet? That's what I would do.
Maybe what you would do is you would be hiding behind something and you'd say, how do you feel about brothers? You got to ask the black question because if they're not with the thing. No, maybe you just say, what part of are you from?
Oh, I see. Yeah, what part of the demographic?
Well, if you see them goose stepping down toward you, you probably know if you're a Jew or a black person. You may want to let them just pass.
Or gypsies or Catholics.
Pretty much anybody.
Yeah. Anyone non-Aryan.
Wouldn't you ask them how you got there, though? Seriously, what was your technology that got you to us?
Well, I would assume they would see them land in something.
No, but you'd want to learn from
as a scientist, I would compare notes.
Yeah.
And I would do things. There's certain things that should be common between us, even if we don't otherwise speak the same language.
What is this thing you call tang? Like that kind of thing?
So, but how would I know that, though? That's what I'm saying. I don't know the Tang or the Kardashians or slip-on Skechers. I don't, unless he shows up drinking Tang.
Do you have to ruin every joke and party with your stupid logic?
With the Kardashian underarm and slip-on Skechers. Then I could ask, what's up with that?
Why can't you presume that this life form is smarter and has the ability to see what we've been doing?
Here's what I would say. I want to compare science notes, because science transcends time and space in ways culture does not.
But it doesn't transcend Instagram. If you got a big following, that's all that matters.
So, if I'd verify that they can see in the same wavelengths of light that I can see, they could have completely different senses.
Well, I was going to say medically, you'd probably want to check each other out too, right?
Not first. No,
I don't mean that.
Start
stupid
poking their bodies first.
No, I didn't mean it in that way. No, I'm not talking about like anal probes or anything. I'm just saying you thought of that.
Don't give the alien a bad name now.
No, I'm saying no. Why wouldn't, if you want to check out their mind and compare notes in terms of science, wouldn't you I would physically want to understand their bodies vis-a-vis my vessel.
No.
Their vessel. No, seriously.
No, if I were a biologist, yes, but I'm a physicist, so no. I'd compare. I'd pull out a periodic table of the elements, because that organization is universal. Anyone who knows the elements well enough, as well as we do, would organize them that way.
Okay, but what if somebody that landed was like a creative writing major and didn't care about science?
If they were the first emissary to another planet, I'm pretty sure they would have given them some science.
Yeah, you're just a science snob. Oh, only we're the ones that everybody cares about. Hello, Neil and Paul. This is Julian Ray, Atlanta native writing from downtown Manhattan. My question relates to stars and black holes. I understand that our sun belongs to the third generation of stars since the Big Bang. Each star will eventually die out in an explosion, some of which form black holes, ending in eternal singularity of their mass. Is it possible that in the distant future there will be more black holes than stars, since their lifespan is so much longer than that of a star? Could the passage of time create a population of black holes that outlive and nearly replace stars?
Yes. Next question.
Okay. That was
So it turns out, according to Stephen Hawking, black holes actually evaporate, but very, very, very slowly.
So it's not burnout, it's evaporate. It's a different...
Yeah, they wouldn't burn out. Very, very, very slowly. So there's a point where all the stars burn out, and they leave their corpses. Some of those corpses are black holes. And there will come a time when the black holes outnumber the living stars. They will never outnumber the corpses.
But isn't the black hole then like, it's like the Alice in the Brady Bunch with a giant vacuum cleaner? It's like sucking up all of the stars, whether they evaporate or not?
I don't... Alice in the Brady Bunch?
Yeah, the housekeeper.
Is that what she did?
She would vacuum.
The black holes?
Yeah.
I'm sorry, I can't connect. I'm sorry. But do you see, where was Alice in the grid of 9 squares?
She was in the center.
She was in the center. And if you notice, her image kept repeating back and forth.
Because they didn't have the technology.
It was a pretty short loop.
Right.
And I got annoyed by it.
It's the same thing in the Mad World.
Yeah.
I just saw it last night.
Really?
No, I'm serious.
Okay, I know every frame of that movie.
Okay, so there's the shot when at the end Spencer Tracy is hanging onto the edge of he slides down a cable and goes through a window and is sitting there, and a Great Dane is licking his face.
Yes, and that's a repeated.
And it's a repeated, and it was annoying me as well. I don't know how he got off on that, but it's like, and he's doing this with his eyes moved the same way. But is it possible there are already more black holes than stars in our universe?
No, because we know who the progenitor is of a black hole. And it's a star that's made 1 out of 10,000 stars. 1 in a million star. It's the most massive of stars is a black hole. And in any volume of gas that creates stars, it creates a lot of low mass stars and fewer middle mass stars and very few high mass stars.
So is this like a cosmic game of hide and seek? In a
Well,
way?
it's called the initial mass function specifically, and the initial mass function favors low mass stars, and high mass stars are just rare. And I don't know the latest iteration on the initial mass function, but it's at least as rare as 1 in 1,000 stars.
That what?
Are massive enough to make a black hole at the end of its life. So all I'm saying is we have stars today that are born out of these pockets of gas that are still alive and thriving, and we've only had 1 or 2 black holes. So no, black holes do not outnumber stars. By the way, they will outnumber stars in a few trillion years, when the lowest mass stars burn out their fuel.
Which just sounds like stars need like a support group for black holes in the way they get dealt with.
No, they'll be fine. Black holes need no support.
The more black holes that develop, we're all in jeopardy, no?
I just avoid them, that's all.
Well, but what you do emotionally in your relationships to other people is not what's relevant here.
Yeah, we just need a map of where all the black holes are, and then step around them. Especially in your time machine. You don't want your time machine to land in a black hole because you didn't type in the right space-time coordinates.
All right, let's move on. I think we answered that thoroughly. Cesar Fredique from Bogota, Colombia.
Love it.
Speed of light, c, shapes our reality and its fundamental properties. However, it is intriguing to consider that regardless of the unit used, c could potentially be half, double, or any other value. Could you suggest factors, other than the possibility of it being an imposed constraint within a simulation, that might determine the seemingly arbitrary value of this universal constant as we understand it?
Wow. Here's a couple of speed of light facts.
299,792,443 meters per second.
Yes. Yes.
And do you know where the c comes from? The Latin word speed?
C stands for constant.
Yeah, but they think that there's a speculation from a 1922 historian and scientist that it's cilitrius, the Latin for speed.
That's the first I've heard of that.
Well, that's why I'm here, to open your horizons.
That's the first I've heard of that.
It's true.
First I've heard of that.
That doesn't mean it's not.
It's the most fundamental constant in the universe.
Right.
And the word constant begins with a C.
I understand that, but there's another.
If I'm wrong, I'd be intrigued to learn that that's what was really going on.
Okay.
It's not just an after-the-fact suggestion.
Okay.
So the units are arbitrary, completely arbitrary. You said how tall are you? 5'9"?
Mm-hmm.
If I measured your height in units of 5'9"-ness, then how tall are you?
Those number of units of 5'9".
If I have a new unit that's 5 feet 9 inches,
and I'm 1 unit.
You're 1.
Okay, so your point being
That doesn't make you shorter or taller or anything.
But your point,
I'm saying that the units are arbitrary, but the speed that we're measuring is not. That is real and it's fundamental.
So the units don't matter.
And so precisely do we understand the speed of light. It's been measured so precisely that it defines the length of the meter. That's how well we know the speed of light. So if we get another point of precision in the measurement of the speed of light, it affects the definition of the length of the meter.
So you can vary that.
Well, only in the points where it's still uncertain. That's correct. But it's the most amazing fundamental thing there is. And
so there cannot be any inherent uncertainty around the speed of light, is what you're saying.
Whatever uncertainty there is, it's smaller than our capacity to measure it.
Then how do you know that there is uncertainty if you can't measure it?
There is always uncertainty in every measurement.
How do we know that?
Always.
How do we know that?
So how tall are you again?
5'9".
Are you 5'9" and a quarter? Are you 5'8" and 3/4? Are you 5'8" and 7/8? Are you 5'9" and 1/8? Are you 5'9" and 1/16? How come you gave it to me in units of inches? You've approximated, haven't you?
Well, it depends on what socks I'm wearing.
You have approximated it. So now I measure you at 5'9". Let's say you're exactly 5'9", 5 feet 9 inches. What does that even mean? The thickness of the line that's the 9 inches above the 5 feet, where are you within the thickness of that line?
Right.
Are you 5'8" and 99/100ths of an inch? Are you 5'9" and 1/1000th of an inch?
So you're saying exactitude is impossible.
Correct.
Always everywhere.
You can never measure something exactly.
Is that because of the space-time continuum?
No, they're what's called measurement errors, but they're not errors, they're just measurement uncertainties. So if you were once 5'8" and then you're later on 5'10", there was a point in your life where you were exactly 5'9", but you could have never measured it to be so.
Right.
All you could do is measure it and bracket it according to the uncertainties of your measuring device.
Right now, I'm exactly 5'9". I felt it.
With a little vibration.
Little vibration.
So measurements are never exact.
And they never can be.
And they never will be. That's correct. You can only know them with greater precision.
And you're how tall?
At my tallest, 6'2".
But you're shrinking.
Yeah, I'm probably shrinking.
Is that your spine collapsing?
The discs between your spinal column.
Fluid.
Yeah, but you can go into space and grow an inch or so. In fact, your space suit that you walk in the spacewalk, is made taller than the one you took off in.
Why are we growing? Because gravity.
Gravity's no longer squashing you.
So the atoms are getting stretched.
Yeah, the molecules, it stretches out, right. So I'm probably 6'1 3/4" now, I guess.
You are, as they say in science, a tall drink of water. All right, here we go.
Doesn't that mean you have great affection for me?
Knows no bounds. It's boundless. All right, Stephen Summers. This is from Heston, Kansas. I was making my way through
These are some small towns. I love it.
Yeah.
Okay.
Making my way through your old queries and found one where you talked about how if we could pass through wormholes, then gravity would as well. But my understanding is that gravity is the warping of space, and since a wormhole is making a hole through the dimension of space, would it be warped on the other side? Furthermore, if a wormhole is a literal hole through a dimension, would we be able to pass through it or even perceive it as beings who live within our three-dimensional space?
Wow.
You want me to
that sounds like he wants to write the sequel to...
Do you want me to repeat anything?
No. He wants to write the sequel to Interstellar. That's what he's trying to do there.
Yes, exactly.
So a wormhole uses, if we were to make one, uses negative gravity. So we know how to make a wormhole. We just don't have the substance to make it happen. Gravity collapses space-time on itself. Negative gravity, if we could negative matter, would pry open space-time.
And creates a shortcut through.
So if we did that, we, in principle, should be able to position it in such a way that pops a hole through the fabric of space and time, and you step through and you're instantly on the other side, which, by the way, would have rendered transporters completely obsolete in Star Trek. Think about it. Just step through a wormhole to get down to the planet.
Yeah, but there's no guarantee you're going to get through without getting lost. It's like Google Maps and you take a right and then suddenly you're in a cornfield.
I'll take that chance.
Because you don't pay attention to Google Maps.
I'll take that chance over dematerializing my body into energy and rematerializing it back into matter on the other side.
Why do you think that that's not possible? Because you're like, your nose ends up on your butt cheek?
Anything. My thoughts, my memories stored in the synapses of my brain. I don't know what's going to do to that. No.
Maybe you could help. Let's say you misplace your keys all the time. Suddenly things get rearranged. You know where your keys are at all the time.
That's a possibility. But the brain is so complex, I'm guessing that if you dematerialize it and rematerialize it, chances are you'll mess it up rather than improve it.
Okay, but if we're 3D and a wormhole is in another dimension, how do we even know it's there? It's like trying to change a flat not knowing where the car is.
We see the part of the wormhole that intersects our dimensionality.
But it's only part of the wormhole.
Well, so here's an example I gave in another show. If we live in a flat sheet of paper, and then we're just standing around and we see a dot just appear out of nowhere, that dot becomes a small circle and then a big circle. We're just watching this. Okay? And then it shrinks back again, becomes a dot, and then disappears. That'd be freaky.
No, that's called a Vegas act. It's a magician. He works at the lounge.
It's completely freaky.
Bellagio.
What you just witnessed was a three-dimensional sphere passing through the two dimensions of your world. And you described it as a point and then circles that grew. until the circle was as wide as the diameter of this sphere, and then it went back and then disappeared as it passed through to the other side. So, higher dimensional things passing through our dimensionality will manifest in some way or another.
So in answering this question, then, the answer is if a wormhole is a literal hole through a dimension, will we be able to pass through it or even perceive it as beings who live within our 3 dimensions?
Yeah.
You can perceive
You would see
it,
the part of the wormhole that intersected our dimensionality.
but
That's
nothing
correct.
more than that.
You won't appreciate all of what else is going on there. The fact that it moves into a 4th dimension, you're not going to catch that.
But if you're passing through a wormhole, you're going to instantly get to the other side.
Instantly. So, with movies like showing that you're going through this tunnel, it's like in the water park. No, it's correctly done in Rick and Morty.
Which is exactly why I watch Rick and Morty, for my science knowledge.
And this dude, what's his name? Dr. Strange.
This,
You know what I'm talking about.
I would, if I had a superpower, I just would want to be able to do that. It's a very sophisticated, understated. It's not this. It's not trying too hard. It's like,
Yeah, I mean, I prefer the Rick and Morty wormholes because Rick uses real science.
And what is it about that wormhole in Rick and Morty that's accurate to you?
No, he just uses real science, whereas Dr. Strange uses magic.
If you can't perceive a wormhole, aren't we in a way like walking through life like this tourists that are lost in New York City, just looking up, taking pictures of everything?
Yes.
And isn't there a way that science can sort of make us not feel that way?
Deal with it. You can't become a scientist unless you are comfortable being steeped in ignorance.
Okay, so we have this constant debate. This is where you just like try to get off on being lazy and not trying to get stuff right.
No, I want to get stuff right.
Well, it's better to not know anything. All right, let's go have a bottle of wine.
No, it's learn to love the questions themselves.
Oh, my God. I went through law school. I don't need this agita. Answer a friggin' question, will you?
Next
talking
question.
to you about science is like looking at a Picasso, and then you're like, whoa, why is the nose on his calf? I don't know. And then some historian, art historian has a theory, and they're completely full of you-know-what. Okay, you know what?
Nose
You're
on his
fired
calf.
from science.
I
I'm
don't think he
taking
ever put
over.
his nose on his calf.
Yes, he did. All right, here we go. Oh, this is Captain Carl with 2 Ks, everybody. Ahoy, Captain Carl from St. Thomas, U.S. Virgin Islands. I've often wondered as a photographer and as physics enthusiast, is our colorful world a result of our white star? White being made up of all colors. What if our planet, or any planet, was orbiting a blue or red star? Would our world be different shades of red or blue? By the way, I just want to thank you, Neil, and shout out to your comedic sidekicks. So would our worlds be different shades of red or blue if we were orbiting a blue or red star?
With our current eyes, yes. But if we evolved there, there's no reason why our evolutionary path wouldn't have divided up the blue light into different subcategories.
Yeah, but if you have pure red, then the entire Earth's going to feel like a brothel.
Yeah, however,
Don't pretend you don't know what that is.
the width of our sensitivity to light is much greater than any single band of light.
Say that again. You lost me.
All right, so you have Roy G. Biv. Do you know Roy G. Biv? You don't know Roy? Red, orange, yellow, green, blue, indigo, violet. Roy G. Biv.
Okay.
You never knew that?
No, I never heard. No.
You gotta learn something every day.
Yeah, that's why I'm here.
Okay. Okay, Roy G. Biv. We see all those colors. Now, when we make color photos by Hubble or the James Webb Telescope, in the infrared part of the spectrum, you can't see colors in the infrared part of the spectrum. So you know what we do? We take RGB, slap it onto different wavelengths in the infrared part of the spectrum, and create a color photograph out of it. That's what you would see if our sight was shifted to the infrared part of the spectrum. It's what the world would look like.
So the infrared part of the spectrum, is it neutral in color?
You can't detect it at all. But if we evolved to see it, there's no reason to think our brain wouldn't assign colors to it. That's what's going on here. We're assigning colors. In fact, Richard Dawkins, the evolutionary biologist, thinks that bats actually, when they echolocate, they see in color because their mammal brain has that capacity. So why not use it? So when you're using echolocation, tag it with a color.
So if we orbited a blue star, would we still have clear skies? In other words,
If our eyes evolved in this star and then transport us to a blue star, right? Then we would not see colors in the blue because we can only see colors in the visible part of the spectrum. There'd be blue and ultraviolet. We only see colors in the visible part of the spectrum. However, you can fake it, authentically fake it.
That's called the perfect Instagram filter, right?
So going in that direction, we have violet. Take 3 bands in violet light that are adjacent to one another. Then once you do that, you assign RGB, bring them back together, and you can reconstruct what you would see if our sensitivity were shifted to the violet and ultraviolet part of the spectrum, to the blue part of the spectrum. So we should think of it as shifted color is what it is.
But we're only limited in how much we can, our abilities to shift.
We're very limited.
Well, you are. I'm not.
So we see red through violet. That's it.
And that's
if I want to see color anywhere else, you take out the RGB, slap it down on 3 different bands, and out comes a color picture of X-rays, of infrared, of ultraviolet, of gamma rays, all the above.
And so a red planet, a blue planet, a red star, a blue star. Is there any star with a color that you have the ability to see without sort of slapping doing that technique?
RBG?
Yeah, RBG.
Roy, say it. Roy G. Biv.
Roy G. Biv.
So no, just the way we evolved, we can't see into it. So, by the way, this band of visible light is very narrow compared with ultraviolet or infrared. Very narrow. So we're practically blind no matter what. And insects see into the deep ultraviolet. Insects. And they're perfectly happy.
When I stare into a very bright light and then I can't see for a second, what's happening?
That's a different thing. You overstimulate the retinal cells.
Which
they have to recover.
Yeah. Which takes several seconds.
Yeah.
Which is always fun, by the way, after you've been drinking. All right, another question. Hello, I'm John Mayhoy. Mayhoy, there you go. And from Parkland, Florida. I know that the cosmic microwave background is like a snapshot of the early universe, and its temperature has been dropping ever since. So I'm wondering, could this temperature be used as a kind of universal clock? If we could measure it super accurately, would that tell us exactly how old the universe is right now? Would that age be the same no matter where you are in the universe?
Yes. Because every part of the universe was in the same place at the same time 13.8 billion years ago. So, the oldest things in the universe, in every direction you look, are exactly the same age, traceable to that period of time. So, yeah, everything. Now, at this moment, we see in the past. So we can ask, what is that thing doing now? Well, it's even farther away from us. And we can think of the diameter of the universe as how big the universe is today, even though you can't see that. And that diameter is coming in at 96, something like that, billion miles, full diameter. So if you could see those galaxies at our horizon today, that's what they look like. But that would need an infinite speed of light.
And that's...
we're not giving you that.
Why? Not possible.
I'm not giving it to you. Observational limits on the universe.
And temperature is the only way to measure this, is to have a universal clock? Is
temperature also works. Yeah, so as the universe grows, the temperature cools. So it's a one-to-one correspondence. So you can just backstrapolate to the early universe.
So there's a murder scene, and they do a forensic...
Why are you so morbid?
Well, because that's how my brain thinks. And so they can figure out based on the temperature of the body when the body died.
Yes.
So that's what's happening there.
I hadn't thought about it that way, but that
right.
works.
Yeah, you got the crusty old cop, and then you got you got the sexy sidekick.
That's right.
Male or female.
I hadn't thought about that.
Well, that's why I'm here.
What's the next question?
Okay. This is Joe Liparella from Pennsylvania. Relativity tells us that as an object approaches the speed of light or is in a deep gravitational well, time slows to a stop relative to other observers. My question is, what is on the other side of that extreme? If an object is motionless and if there is zero gravitational effect on it, how would time work for that object?
If there's zero gravity, then time goes fast for it.
Well, an object is motionless, and if there's zero gravitational effect on it,
Right. So
how would time work?
when you are in the presence of gravity, you age slower.
So this is like the ultimate anti-aging hack. We should bottle this. We should be on QVC right now, not on this dog and pony show you call StarTalk. We could be making some big bucks.
Start our own QVC channel.
Yeah, Dr. Tyson's QVC hack.
So what are they asking then?
They're asking, my question is, what is on the other side of that extreme? In other words, relativity tells us that as an object approaches the speed of light or is in a deep gravitational well, time slows to a stop.
Okay, so now watch. So some years ago, people realized you couldn't accelerate past the speed of light. But does that preclude a particle existing faster than light? If you can't accelerate past it, can you exist on the other side? And serious thought was given to that, to the point where there's some movies based on it. And there was a hypothetical particle that has these properties. It's called a tachyon. Tachyon from the Greek meaning fast. Tachyos. Tachyons. And tachyons would live backwards in time.
How is that possible?
Because if time slows down as you reach the speed of light, on the other side of speed of light, if you continue the equations jumping that gap, time would go backwards for it. Tachyon. Yes. Yeah. For it.
Do we know they exist?
No, we never found them.
So then how could you have a theory about something that you like?
Because it's allowed to exist by Einstein's equations. And if something is allowed, that's good enough reason to go out and look for it. If other parts...
But at one point, do you stop looking in all seriousness and go, well, this doesn't... If you can't find it...
Welcome to the frontier of science.
No, it's like I can't find my phone in my house. I'm not going to keep looking and go, I know it's there.
We don't know. That's right. It's a mystery. But if you give up and someone else finds it a month later...
So when time meets an object with no gravity and no movement, it's like my lazy, good-for-nothing 15-year-old son who won't mow the lawn, right? He just sits there. So the answer to the question is yes. Is it that clear?
The answer is... Wait, weren't there two parts to that?
There's the an object approaches the speed of light or is in a deep gravitational well. Right. Time slows to a stop.
Yes, in a deep gravitational well. Yes, time slows.
Okay.
Correct.
And what is on the other side of that extreme?
And that would be tachyons.
Tachyons, which we know there, but we haven't found them. Okay.
Correct.
Got it.
The tachyons work in the equations.
So as a result...
And so we're saying, well, to write all these other ways, maybe this prediction of the equation should work as well.
Got it.
So if you are motionless in space, as far as you're concerned, you'll still have your own timeline, and all that matters is what other people will say of you as they fly by you. So everyone will have a different time reference for you. But all you care about is your own clock and your own wristwatch and your own clock on the wall. And that's all you care about. Now, that's if you're not moving. But if there's no gravity, then time speeds up for you.
So if an object is motionless and there's zero gravitational effect, how would time work for that object? This is where we're talking. This is where we were joking about anti-aging hack, right? So in other words, there'd be no aging because time. There's zero gravitational effect.
Yeah, but you and everyone else around you, in your same reference frame, will age at exactly the same rate. It could be 1 second for every 10 seconds outside of your club. Right. But it won't matter to any of you. You can't hack that system and say, I want to go back to when I was younger.
Okay, but if you're so smart, tell me who in that group is going to get plastic surgery first to avoid the aging process.
Yeah. Plus, if you're in space with zero G, some surgeries aren't necessary.
No. Well, it's right, because you got nothing pulling on you.
You have nothing pulling on you. Stuff floats.
That's what we should invent. We should invent zero G facial surgery. I like this question. It's very simple, straightforward, but interesting. Dennis Alberti, please explain buoyancy.
Buoyancy. I love it. All right, so it's all about density. In the end of the day, it's about density.
And gravity,
So if you are, and gravity, yes. If you are less dense than the medium you're immersed in, you will float to the top. It's that simple. It's not more complicated than that.
Define density.
It's how much matter you can cram into a certain volume. So the big advance, it's amazing this didn't happen until the 19th century, there was some early variants in the 18th century, but it really took off in the 19th century. The fact that you could float metal. If you make a boat out of metal, then it's almost impervious to war.
Not icebergs. And $1 billion gross at the movies.
It's exactly what Titanic did, but probably up to 2 or 3 billion now.
Look, to summarize it, a submarine is a boat in denial.
Well, so here's what happens. So
You should react to that. That was a good line.
So
A submarine is a boat in denial.
So if you have a hull that's made of metal, any bits of that metal would just sink to the bottom. However, if it's in the hull shape, it's pressing down on the water is rising up, and you've created an environment that on average is less dense than water, and so therefore it floats.
Because of the V-shape.
Because most of the volume is air. So you get to add the air plus the metal as part of the contents that's within the volume. And when you do that, you systematically reduce the density of the material. If you go back 1,000 years ago, people made boats out of wood, sensibly, because wood floats. So you would make anything out of wood, it would float. That made complete sense, but you're susceptible to attack.
But if I took a metal plank, a 4 by 12 piece of metal, flat, and threw it in the water, would that sink?
Yes.
Because you don't have that V shape, you don't have the relation to air.
Because it's all about volume. It's all about volume. So if you carve it into a volume, then it's the mass of the shell divided by the full volume of the whole thing, and that gets very low. It'll be lower than water. It'll just float.
It's the same principle why an iceberg can float, because you
icebergs are just simply less dense than water.
Right.
Simply less dense.
So you don't need that V shape for that to.
For an iceberg, no. No. I mean, you don't ever need a V shape, except that, I mean, like styrofoam will make a boat, but it doesn't need a V shape.
Right.
V shapes are important if you know the material you're working with is heavier than the stuff itself.
Right. Because you want to displace.
Correct.
Right. It's all about displacement.
Correct.
So the bottom line is icebergs float. You got a V-shaped hull, steel, float.
Yes.
Styrofoam cooler, best scenario. You can sit on it and tap in and get a couple of beers at the same time.
At the same time.
Okay, that's why I'm here.
Paul, got time for one more.
One more. Got it. Okay, this is actually a very interesting one. Terry Burke from St. Louis. My question is simple. In nuclear fission and fusion, a small amount of matter is lost and converted to a large amount of energy. Is the gravity associated with the lost mass also lost?
No, because, great question, by the way, gravity emanates not only from mass, but also from energy. Because mass and energy are the same thing, different sides of the same coin. So you're not just losing mass and not energy. You're losing some combination of the two, and they go hand in hand.
So the answer is no. Is the gravity associated with the loss?
No.
And that can never vary. I mean, this is a constant. This can never. The idea that gravity associated with the lost mass is also lost.
Oh, matter and energy are one and the same thing. Mm-hmm. So they each distort the fabric of space and time, and that's all you need to know about it.
Okay.
Mm-hmm. We will commonly think of matter distorting space, but if there's energy there, it will distort space as well. And E equals MC squared reminds us that they're two sides of the same coin.
The more the amount of energy is created is the same amount of gravity lost. In other words, like the mass lost is the gravity associated with the lost mass is also lost. Do you lose more gravity the more energy that's created?
If it leaves the system, yes, you're losing gravity anytime any matter or energy leaves the system.
No, I know, but doesn't it sort of all change over time? And depending on the amount of energy that's created. The more energy that's created, the more gravity is lost. No?
Yes. But it's a lot of energy and a very small amount of mass, so I wouldn't lose sleep over it.
Well, listen, it's up to me what I lose sleep over. Just because you walk through life not caring about science the way I do, I can't.
It is weird, though, that humans, for 1/3 of a rotation of the Earth, are semi-comatose. One last question. I'll do it.
One last one? Quick one?
Soundbite.
Okay. Markler.
I used to have a bell here. I don't know what I did with it.
I'm Mark from Portland, Oregon. Is our solar system comprised of remnants from a single supernova or a collection of many? If many, I'm curious how any galaxy diffuses multiple supernovas together.
Okay, so first, a supernova is a huge explosion, and its guts are just scattered everywhere. Just start with that. Then, the galaxy rotates, as we say, differentially. So the inner parts complete a circle faster than the outer parts. This shears the gas clouds that have all been contaminated by the detritus of a supernova explosion. And you get a few rotations of the galaxy, this stuff becomes very well mixed. And the next generation of stars is going to have all the ingredients from that last round of supernova explosions.
So it's like fertile ground for the next round.
Yeah.
Got it.
All the way through.
All right, I think that's all
These are
our
good
time.
questions. Wow.
Yeah, excellent.
All Patreon members, but this is for our general audience.
General audience.
By the way,
CQ
if you join
grab bag.
Patreon, we do special custom Q&A sessions just for you, and that's on the other side of the Patreon paywall.
Yeah, and it's worth paying because we dress up as Elizabethan characters when we do that CQ. So, but that's what you're missing because you're too cheap to join. All right, good for you. Oh, and we give out gold bars to everybody.
That's when I have
And
to pull out that
puppies.
sword, and that sword, you see, I got to use that sword.
Right. And every Patreon member gets a puppy.
And a pony.
And a pony.
All right, we're done here. Yet another installment of Cosmic Queries with Paul Mecurio. Paul, we'll find you your show on the road.
Yeah, paulmecurio.com.
Did someone say, take that show on the road? And then that's
they
what you
said,
did?
I did it in New York, and then the authorities called and said, take it on the road. And Inside Out with Paul Mecurio,
Inside
my
Out.
podcast.
Isn't there a movie called Inside Out?
There is, but thanks for bringing that up. This is how you help me get people come. Oh, yeah, you just copied something, so don't go see it. Yeah, Inside Out
No, it
with
has
Paul Mecurio.
good interactions with the audience. You're very good on your feet in that way.
Yeah, my show Permission to Speak is about sort of engaging the audience in their stories. It was born out of crowd work with an audience.
Yeah, good. Love crowd
fun.
audiences.
But it's but people have
And your
fascination.
podcast?
Inside Out with Paul Mecurio.
Which I've been on.
Yes, you've been on.
Yes, I
and,
have.
Paul McCartney and Stephen Colbert and a lot of fun people. So
Well, I wasn't enough to...
you were. Wow. The only reason Paul McCartney did it is because he found out you did it.
Oh, see? That's what I expect.
And he knows a lot more about the theory of relativity than you do. Weird. I don't know, because I just thought he played music. No. Yeah, so hopefully people can check all that stuff out.
Yeah,
PaulMecurio.com.
we'll look for it. You got it. All right. This has been StarTalk Cosmic Queries, Grab Bag Edition. Neil deGrasse Tyson here, thanking Paul Mecurio. As always, I bid you to keep looking up.